Welcome aboard, everybody. We are live. We are live and rolling. How's everybody doing today? Hope we're doing great. Oh, I've got a bunch of experiments ready for us today. How you doing there, noob? Hello there, Windexian. Hello there, Charlie. Figured we'd do some, start off with some acid-base experiments. Excuse me. And then we'll head on to, I think we're going to do some of those mixing experiments. Yeah, for now, let's just enjoy some of the color changes here. Hello there, School Halloween and Charlie Dead Girl, and great to have you all on board. Great to have you all on board. Let's do a couple drops. Let's do like 2, 3, 4. 1, 2, 3, 4. Nice. Hello, School Halloween. I had some other experiments ready for you, but just right before I started the live, it got screwed up. So I do have other experiments ready, but I had a third ready that's not going to work. Isn't that beautiful? Hello, Bryson. Yeah, we're just doing the old, to kick us off, we're going to start with the acid-base experiments. Just to remind ourselves, because we're gonna refer to this later in some of the experiments that we're going to do. So yeah, right now we got a pH of 3 over here. I'm going to add a little bit of base. We're going to watch what happens. Thank you there, Real. Tell me about it, Windexian. Tell me what you're talking about there. That wouldn't... Oh, look at that. We got a rainbow flash. Yeah, noob. I mean, we can start the experiment right now if you want. I mean, I got some other stuff ready. If you want to, we can go ahead and do that. Let me, this one takes a little bit more time to change back and forth. Look at that, though, huh? Just cool. Just cool. Let me get this one all going. Oh, do I have water down here? I hope I do. If I don't have water, I'm in trouble. Let's get this guy going here. Okay. Thanks, Ariel. Appreciate that. Let me know what you see in the in my lives that you like, or in my YouTube shorts. Let's pop this bottle up here. Let's do this experiment. All right. So I've got a little bit of this fluid here. I'm going to top it off. Let's top this fluid off. Oh, where's do I have? Let's see if I don't know if I'm going to need a funnel or not. Let's just see if I can pour it in there with a steady hand. Steady enough, huh? That looks kind of cool. Look at that mixing. Interesting. I'm going to top this fluid off. Pretty close to the top. All right. That looks pretty good. And now, what I'm going to do to this, you might notice it looks like there's 2 layers there, yeah? Do you see it? See how there's 2 different layers? Yes, indeed, there are. And now what we'll do is I'm going to add some of the same dye that's contained in this flask. We're going to add it to this one over here, okay? So let's do that step. Here we go. What I'm adding is universal indicator. It's also known as rainbow indicator. It tells you the pH of a fluid, and the pH just tells you how acidic or basic something is. Probably Windexian. So you see here, this stuff is green. Watch what happens when I add it to this fluid here. It's like it turned yellow, huh? What's going on, Future Farm? So, Yeep, what this is a flask on the right. It's a flask on the right that contains water and some isopropyl alcohol. And now I'm adding some universal indicator. And you might ask, well, what is universal indicator? Well, to give you an idea what universal indicator is, look at this flask over here. We're going to do some experiments on this in a second. But if you look at this flask over here, which has universal indicator, you can see it's red. That tells us its pH is 3. In this container over here, it looks yellow, so the pH over here is like pH 6. If I add some base to this flask over here, sodium hydroxide base, let's add a few drops. I see violet. Let's see what else we see. Yeah, Future Farm, there is some phenolphthalein in here. Is that another drop? Boy, there's quite a bit of acid in here. I can tell because I'm needing to add quite a bit of base. Each time I add a drop of base, you'll notice it turns violet here. And that's because the base is going to be like pH 10. But yeah, there's quite a bit of acid in here. I'm trying to neutralize it. There we go. I think I've added enough base now. Those two should react. I don't know where the pH is going to land. It looks like the pH rose just a little bit. Maybe to pH 4. Let's add another drop of base. Let's see what happens now. It sure did, Future Farm. Oh my goodness. Now the pH has risen. You got it, Yeep. pH has risen to about 9, 8 or 9 at this point. One more drop of base should get us to pH 10. So that's all. That's what's in this container over here. Some of this universal indicator, some alcohol, and some water. Let's mix it up. And then we'll continue to do our experiments. All right. So here we go. Let's mix this up. You can see 2 layers. If you look careful, you can see sort of the water on the bottom and then this alcohol layer on top. Let me mix this up so everything mixes together. Now, alcohol and water mix in all proportions, so those 2 layers should disappear when I mix everything up, so that there's one single fluid layer. And it's colored yellow, and that tells us, of course, that the pH of our solution is pH 6. Yeah? Yeah, pH 6. Okay, but we're not done over here. Look at all those bubbles, huh? Those bubbles are cool. But yeah, we're not done with this over here by any stretch of the imagination. Now to this flask over here, I am going to add some table salt. All right, I got my table salt. I need to get my funnel so I can pour it in there without making too much of a mess. Here's my funnel. All right, let's add the table salt, mix it up and see what happens, okay? Here we go, baby. Again, let's remind ourselves what's in here. We have water, we have isopropyl alcohol, and we have a little bit of this universal indicator that shows all these different colors at different pHs. So we know we got a pH of 6 over here. I'm going to go ahead and add the table salt. Here we go. You can see the funnel at the top. In goes the table salt. Looks nice and cloudy as the solid goes in. Hopefully it doesn't quite go over the top. Oh, almost over the top, but we're good. Let me shake this baby up. And let's see what happens, okay? I'm going to cap this off. And we're going to shake this up. It's going to take a little bit for the salt to dissolve. So while I'm doing this, let's go ahead and add like acid or... Excuse me, I'm going to add acid to this. You can watch the colors change as I add some acid over here on the left. Let's see if we can get the pH to drop as I'm mixing this up and trying to get the salt to dissolve. So yeah, over there on the left, you can see that as I'm adding acid, the pH, well, the colors is what you're seeing. The color is changing from a purple to maybe more blue or green. That just tells us the pH is dropping. It does a little bit, noob. There we go. I'm just continuing to add acid to the flask on the left. And it looks like I've got it all the way to where it's acidic. So, Cheng Li, what I am doing is I have taken a mixture of alcohol and water and a little bit of universal indicator, and I've added some salt to it. And now I'm shaking it up because I'm trying to get as much of the salt dissolved as I can. And if I get enough of that salt dissolved, we should see something interesting. I think it's ready. Let's see. I'll be able to tell pretty quickly. Is it working? So, yeep, not all acids react with glass. There's only one acid that reacts with glass, and that's hydrofluoric acid. The acid that I've added over here is hydrochloric acid. That's the same acid that's found in your stomach. That does not react with glass. It is working. I think it's working. Yeah, it's definitely working. It's just going really slowly. So if we look over here at this flask now, over here on the right, we can tell something's going on. If you look down at the bottom, it looks a little bit colorless. If you look at the top, it looks more orange-yellow, and in the middle, it looks kind of yellow. Now, what's happening here is the alcohol and the water are separating. You see, when you add salt to a mixture of water and alcohol, the salt and the water attract each other so much. That's down here. This is now salt water. They attract each other so much that it forces the alcohol out. So this part here in the middle is a mixture of the three. It's a mixture of the salt, the water, and the alcohol. We call this an emulsion, but it's a transient mixture. It doesn't stay forever, and that's because the water and the salt particles are attracting each other, and they're heading down here, and they're pushing the alcohol out. It's kind of like when two people love each other so much that they date each other exclusively. They push out all other suitors. That's what's going on here with the water and the salt. Is the pressure building? I don't think the pressure's building. Alcohol got evicted. That's another way to think of it, for sure. And at this point, we almost got the emulsion layer gone. Almost. Almost. Thank you there, Soto. I'm going to just shake this just a little bit more. Yeah, I can still see there's just a little bit of undissolved salt. Just a bit. Shake it, shake it, shake it. Here we go. Let's see how that works. And now what we'll do as the separation happens, now remember, this is an acid-base indicator in here as well. So it is not drinking alcohol, Cheng Li, it is rubbing alcohol. So drinking alcohol is a 2-carbon alcohol. This one that I'm using is a 3-carbon alcohol. So as this separation occurs, because I have an acid-base indicator in here, what we're going to do is we're going to start to add, let's add some base, shall we? So if I add base, right now we're at like pH 6, right? So if I add base, the pH should rise. So let's just add some base to this as the separation happens. So in goes the sodium hydroxide base. Let's see where it goes. You can see it. Well, if you look carefully, you can see its trail. You can totally see its trail. The base, that's really beautiful, actually. That's really kind of cool. Oh, that's beautiful. That won't explode. Yeep, water that is purified, perfectly purified, will be neutral, but very few samples of water are pure. They have carbon dioxide dissolved in them, and that makes it slightly acidic. This is really looking cool. So you can see where I've added the base. There's sort of a trail of green. That's where everything's been neutralized. And then down here where the base has entered the salt water, it's violet. That's pH 10. It's not perfectly mixed, which is why you're getting a bunch of different, colors and a bunch of different pH values. Distilled water, the Scaredy Ghost, is neutral if the carbon dioxide has been removed. So if it's not in contact with air, carbon dioxide in the air is going to dissolve in distilled water. And it's going to make it slightly acidic. But yes, if it's perfectly perfectly purified, then that won't be the case. It will be neutral. So you notice I've added 2 drops of base to this flask, yeah? Now 3. Let me shake this up and see what happens, okay? Let's shake this up and see what happens. Sorry to get technical on you, Scaredy Ghost. Here we go. I'm going to shake this up. And you can see the emulsion layer here. It's just barely there. We got the salt water layer. We got the alcohol layer. What do you want me to make, Dark Knight? All right, let's shake this up and see what our pH ends up as, okay? Here we go. Shake her up. Hey, look at that. I think it shifted. The pH shifted a little bit. Our pH shifted to pH 8, yeah? pH 8. So let's see what this looks like now that the pH is shifted to 8. Oh, I'm not going to make anything explode. I don't have the materials for it. Sorry about that. Hey, yeah, Legs wants everyone to know, Legs wants everyone to know, what's your favorite chemical? What's your favorite chemical? Mine happens to be, I think mine's carbon dioxide. Hey, what in the world is going on? Y'all see what I'm seeing down here? Are you seeing what I'm seeing? What's going on down there? That looks kind of violet. We got Yeep saying O2. We got Denise, H2O. Or maybe it's O2. Gallium is very cool, Windexium. Indeed. Definitely helps you stay alive. Isn't that cool? Look at the colors here. So what is that exactly? So what it is, it's a mixture of, on the top is alcohol. It's isopropyl alcohol. On the bottom is salt water. And in that sort of middle layer, that's a mixture of the salt water and alcohol. It's an emulsion. It's a transient mixture that's separating into an alcohol layer on top and a saltwater layer on bottom over time. Yes, Dark Knight, absolutely. Thank you there, Woodbrain. And now there's different dyes in here, and we can see that the different dyes dissolve better in different layers. Down here, we've got some dyes that look purple, dissolving in the saltwater layer, and in the alcohol layer, we have some dyes that appear more blue. It doesn't. Sorry, Woodbrain. It doesn't. So now I'm going to add some acid to this. Now, right now, we're at a higher pH. So long there, noob. We're at a higher pH, and I'm going to add some acid, and that's gonna drop. B. Jurgadin is asking, what is your favorite experiment to do with class? Usually whichever one I'm doing at the time. All right, here we go. Let's add some acid to this. Here we go. Hydrochloric acid, in it goes. Hydrochloric acid, the same acid that's found in your stomach. Let's do like there's 2 drops. You can see it's layering right on top of the emulsion. Isn't that cool? So you see the alcohol layer, the emulsion layer is blue, the saltwater layer is violet, and the acid just went to the bottom of the alcohol. And now we can see that the emulsion layer is completely gone, is completely separated. I'm going to add like 3 more drops of acid. So yeah, you can see the acid is more dense. The acid solution I'm adding, hydrochloric acid solution, it's more dense than the alcohol, but it's less dense than the salt water. It does look a little like a sunset, like it's the evening here, and it's maybe this is like a purple ocean with the sky up here and the sunset clouds here. I love it. I think, Yeep, I agree. It looks a little bit like that. Very, very cool. Does look like a nebula, Woodbrain. Let's give this thing a shake and figure out where the pH is going to end up. Now, I've got some acid in here. So this is like pH 3 or 4 right here. This is like pH 10. I have no idea where this is going to end up. Let's find out. Let's give it a shake and see. All right. Shake her up. Looks like it's going to go acidic. Down to pH 3 or 4. But wait a minute. Wait a minute. Do I see some green developing? Is it like a yellow-green? Slightly green-yellow, I think, is where we ended up. So, the Dark Knight's favorite experiment is when the pre-K teacher didn't think the Coke and Mentos trick would work. And they did it in the rain and got soaked with the sugar. That's awesome. So yeah, this is separating now again. We can see, it's a little hard to see when it's pH 6. The layers are a little tough to see, but you see down there at the bottom that there's a separation happening, right? You see the saltwater layer. The yellow dye does not go into the saltwater layer very well. it goes into the alcohol layer quite well up here at the top. And in the middle, you see a really large emulsion layer. And again, the emulsion is a mixture of the alcohol and the salt water. The reason why the emulsion doesn't last, because in the emulsion there is salt, there is water, there is alcohol, but the salt and the water attract each other so much that they, so to speak, date exclusively and push all other molecules out. So that's why the alcohol is ending up on top. Now I'm going to go ahead and that's the truth, Dark Knight. Here, let's add some base to this. Let's add some sodium hydroxide base to this, see what happens. Here we go. So in it goes, up here at the top. Man, let's add just one drop first, see what happens. You can see the trail of base. Look at that. That's beautiful. You can see the trail of base, right, where the greens and the blues are showing up. So the dye that's in here, for those of you who are just joining us, the dyes that are in here, they show these colors at different pH values. And so most of the flask is pH 6. That's this yellow or this pH 5 color. And when I add base, that's going to add higher pH stuff to it. And that's where we're going to see the greens. Where it's green, it's been neutralized. So you're seeing some green. And down here, we're seeing some violet. If I mix this up, we're recreating Breaking Bad. I don't know about that. Let's add another drop of base here, just for the heck of it. All right, let's see where we end up. I'm going to go ahead and shake this up, and we'll see what pH we end up at. There we go. All right, give it a shake. Looks like it might go green, might go blue. Looks like we're going to get blue again. So we can do that trick where I add the acid again. Okay, let's see where we go. Looking pretty. What is the machine the bottle's standing on doing? It's not doing anything right now, but if I turn this stir bar on down here, there's a stir plate on. So you can see right here, I can turn this on or off. It starts spinning this little magnet in here. So there you go, Yeep. We're back to the other valve for you. We can look at them both. Let's add a little bit of let's add a sodium hydroxide base to this flask over here on the left, while this separates over here on the right. I'll add like 2 drops. See if we get the rainbow, man. Oh, I added too much base. Probably not. Let's acidify it. I'm going to add some some hydrochloric acid. Hydrochloric acid is the same acid that you find in your stomach. It's just that this stuff is like 1,000 times more concentrated. Thank you there, Jergeddon. Thank you there, Gamer. All right, let's add like 2 drops of base over here on the left. 1, 2. Let's see if we get the rainbow now. Come on, baby. Come on, baby. I think it's just a bit too much base. Close. I think we got a flash of the rainbow there. Got a little rainbow flash. Let's add some base to acidify it again. Some acid to acidify it. It is like a forbidden Kool-Aid. 1 more drop of the acid. The acid I'm adding is hydrochloric acid, the same acid that's found in your stomach. 1 more drop. Let's add some acid to this flask over here too, okay? Let's see what happens if we do that. And then I'm going to add 1 drop. Here, let's add the acid here first. Let's go like 3 drops. Ready? 1, 2, 3. You can totally see where the acid... Look at it. Look at that, man. You can totally see that the acid has gone to the layer that's between the alcohol layer and the emulsion layer. Isn't that cool? So you can totally see 4 layers now. There is the alcohol layer that's least dense. Then there's the acid solution that I added, which is second most dense. Below that's the emulsion, and the emulsion is your alcohol and salt water. And down below that's going to be your salt water. It does look cool. We're going to let that set. And over here I'm going to give 1 drop of base, see if we can't make the rainbow for you. Come on, man. Give me the rainbow. Come on, baby. Give me a rainbow. Come on. Come on. There we go. Little rainbow flash. It's not working quite as well as I'd like. I'm gonna pick up the speed just a bit. See if that helps. How are you sure there's not LEDs under it? Well, I don't know. You see any LEDs under there? It's just a flask. I don't know how else to, you know. Is that what you're asking? If you drink that stuff, will you turn rainbow? No, but it might ruin your afternoon. One of the dyes in there used to be the main ingredients in X-Lax, so that should say the active ingredient. All right. So yeah, if I drank it, the live would probably end in 10, 15 minutes, I'm guessing. All right, let's do a drop of base here. Come on now. Come on, baby. Give me the rainbow. There it is. There it is. We got a little purple. We got a little red. A little bit of green. No, I don't think so. I don't think it was good enough. Come on, man. We can do this. 1, 2. Let's get it just red enough. Thank you there, gamer. Let's do 2 more drops here. See if this does it. I'm going to go 1 more drop. Okay. Now, let's add a drop of base. See if we get that rainbow over here on the left. Then we're going to shake the flask on the right, see what happens. I don't think it's going to be enough. 1 more drop. There it is. Rainbow flash for y'all. Kind of cool. Get a little acid up there. Get a little base. So, Jergeddon, you could do this at home. This over here. What you know, the indicator that I use, you're probably not going to be able to get that very easily. But what you could do is you could boil some purple cabbage. When you boil purple cabbage, you get an acid-base indicator that shows a variety of colors. And then you could either add vinegar to lower the pH or ammonia to raise it, and that would work. Tell them, Warren. Tell them. Here, let's shake this up, all right? We've got a bottle here with, well, it looks like, look at this. In the middle, we got pH of about, I don't know, 4, maybe 5. On the top, we got pH maybe 8, maybe 7. And on the bottom, we got pH 10. We're going to shake this up. We're going to see what happens. We're going to see if we have more acid or base. If they're perfectly balanced, we'll get green. If there's more acid, it'll be red, orange, or yellow. If it's base, it'll be blue or violet. And it looks like I perfectly neutralized it. It looks like we have a perfect balance of acid and base over there on the right. Now we're going to watch the separation happen. Here we go. Let's add a drop over here of sodium hydroxide. Boom. Come on, man. Come on, baby. Give me a little rainbow action. Looks blue raspberry, nice. There we go. I'll try to get this just a little bit different angle. See if that helps. Hey, look at this. We're getting a little color separation over here, right? We got the alcohol layer on top. We got the salt water layer on bottom. We got the emulsion in the middle. Hey, Raphael, welcome aboard. Hello, Chiquita83. Welcome aboard. Let's go science, baby. Hey, there we go. Thank you there, Jada. I appreciate that. You might like this. Let's go ahead. How did it change from orange to purple? So, Peter, what's going on here? Let's just talk about this flask over here. So, in this flask, I have added some acid-base indicator known as universal indicator. You can call it rainbow indicator. It displays these different colors at different pH values. pH just tells you how acidic or basic something is. So over here in this flask over here, it looks kind of like a green or a blue. Yeah. And that tells us the pH is 7 or 8, somewhere in that region. So this flask is either neutral or very slightly basic. Over here, this flask, pH of 3, it's very acidic. The further you get away from 7 on the low end, the more acidic it is. The higher you get away from 7 on the high end, the more basic it is. Now watch what happens when I add some base, some sodium hydroxide base. People call it lye. Thank you there, it's the guy. So I'm going to add a drop of base over here on the left. In it goes. In it goes. You can see a flash of color. That's because there's a lot of base and a lot of acid added, and they're reacting with each other, and they're trying to find out where they're going to equilibrate. And it looks like I added much in excess of base. It's looking to me like it's either pH 9 or 10 now. So now what I'll do is I'll add a little bit of acid to this flask over here on the left. Here we go. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. It's just that this is a lot more concentrated. And I have added... I'm sure I'm not, Yeep. Yeah, I've added enough acid that we are at like pH 4 now. Let's add a drop of... Thank you there. It's the guy. Let's add a drop of base over here. Little flash of stuff. This flask looks kind of cooler. The flow patterns you get with this flask are much nicer. I'm using 20% by weight sodium hydroxide. No, Yeep, you don't want to drink it. The one of the indicator dyes used to be the main, the active ingredient in X-Lax. All right, here we go now. Hey, look at this. This is 2 sharp layers over here on the right. I got the same indicator over here in this flask. So let's acidify this. I'm going to add, I don't know, 1, 2, 3 drops of acid. Hydrochloric acid, same acids found in your stomach. It's just, once again, this stuff is a lot more concentrated. And now I'm going to add a drop of sodium hydroxide base. That's going to raise the pH. And it goes. Look at that flow pattern, man. There's some goofy stuff, some goofy fluid dynamics going on. But you'll notice that the material generally stays in the middle. And that makes sense because, you know, this is a lot like a hurricane. And we know that, you know, it's in a vortex. The center of the vortex is low pressure. And material, once it's in a low pressure region, it's going to stay there, right? It's not going to move out to the high pressure zone. There's another drop of base. Look at that. Look at that beauty. Look at that gorgeousness. It's really pretty. Let's add some acid to acidify it. I agree, it's the guy. 1, 2, 3 drops of acid. You can see the red right in the center where the acid's been added, and as it moves out, come on, we got a rainbow flash. Woo! That was cool. That was really cool. All right, let's add a little bit more hydrochloric acid, stomach acid, drop, drop. And it goes. Get that nice and acidic. Now I'm going to add some base. Let's see what happens. The bottle does look like a pill, Yeep. Here we go. 1, 2 drops of base. Look at that. Come on, baby. Come on, look at that. That's gorgeous. Woo, we got the rainbow, folks. We got the rainbow. Here, let's do this. Let's add some acid to this flask, okay? So I'm going to add some acid over here. This is a 2-layer flask. So in this 2-layer flask, there's some alcohol. And then down on the bottom, there is salt water. And they don't mix. So I'm going to add some acid to this, okay? Anyone can do this, Sigma. Anyone can do this. Here we go. I'm going to add a couple drops. 1, 2, 3 drops of acid. And you'll see the acid is more dense than the alcohol layer, but less dense than the salt water layer. You see? How do I know it's acid? Because pH 3, I've added acid. We can tell that that's acidic stuff there. Oh, Redhead, I'd love to meet your kids. I love doing science experiments for kids. It's a lot of fun. Yep. All right, let's do, let's shake this up, all right? Let's shake this up, see what happens. So, you know, the pH right now in the flask on the right, it's probably like a pH 7, right? Maybe pH 8, somewhere in this region. And I've added acid to it. Gosh, that looks like a horizon, doesn't it? Anyway, I've added some acid, so the pH should drop. You know, I think we're going to end up maybe 6, 5, or 4 after I mix all this up. I don't know. We got to mix it up and see. Let's see what happens if I mix this up. Of course, the pH is going to drop. There we go. It's looking like it's going to go yellow. But wait a minute. It's shifting back to the same color as this. Looks like we're at a pH 6. Roughly pH 6. pH 6. Miami Dolphins colors for a second. Hey, they were winning, I saw. They were like what is actually happening in the NFL this year? The Dolphins are beating the Bills? What the heck? That's cool, great color. All right, let's add some acid to this flask over here. Get this acidified. The acid I'm adding is hydrochloric acid, same acid that's found in your stomach. All right. Got that nice and acidified. I'm going to speed it up just a bit. I'm turning up the stir speed. Let's add some base. Looks like I might be running out of my acid. Oh, no, I got another bottle here. I got another bottle right here. We're going to need it. All right, here we go. Let's add some sodium hydroxide base. Here we go. One big drop. In it goes. Boy, that's mixing a lot quicker. Look at that flash. Rainbow flash. Is that another drop of base? Very cool. Beautiful. I'm going to turn the speed down. Let's add on this side. Let's add some base this time, okay? So we're at pH 6 in this flask over here. This flask contains salt water down here, alcohol up here. Here's a mixture of the two. When you shake it up, it mixes, but that mixture separates over time. We can see it's at pH 6. Yeah, it's at pH 6. I'm going to add a drop of sodium hydroxide base. That should raise the pH. In goes a drop. Boom. You can see its trail. If you watch, you'll see the trail of where the base went. You see it? Right through there. How can I tell that's a base? Well, base is going to increase the pH. You'll see like these colors. If it's neutralized, it'll go to green, but it'll be like blues and violets. And look at that. You can see the trail. You can totally see the trail of the base, right? Boom. Very cool, huh? Let's shake it up and see what happens. So if I added some base, that should raise the pH. Right now we're at pH 6. So if I shake this up, our pH should go up. I'm going to add one more drop. Let's add like 3 drops. Let's really get this basic. 1, 2, 3, and see what happens, okay? So I've added 3 drops of base to something at pH 6, yellow, and we're going to shake this up and see what happens. Just looks like nothing, you know? It just looks like just a little bit of green in there, but check this out when I shake it up. It's crazy. The base is really concentrated. So when I shake it, look at that color shift, man. Come on, baby. Look at that color shift. All right, we're going to watch that separate over time. While we're watching this separate, remember, the alcohol is going to go on top. The salt water is going to go on bottom. We're going to add some acid to this flask over here. Thank you there, It's the Guy. Thank you there, Sigma. Appreciate all the love you guys are bringing through. Thank you there, Nightmare. I appreciate that. Appreciate that, y'all. Feel free to drop some questions in the comments for folks to ask and answer. Forgive me, I can't always read the comments because I do pay attention to the reactions and trying to keep my hand. Whoa! It's like we got the same color going on in both test tubes or both flasks, but we have very different things happening. Very different things happening. Over here, so you got to understand that in this universal indicator, there's a lot of different dyes. There's not just one dye. There's actually 4 of them. And some of those dyes dissolve better in the saltwater layer, and some of those dyes dissolve better in the alcohol layer. And that's why you're going to see different colors here. So once again, here's the saltwater layer with this is actually phenolphthalein that's dissolved in the saltwater layer. That's the thing I'm telling you guys. It used to be the active ingredient in X-Lax. Hello there, Ismail. Hello there, Smith. And then the 3 other dyes end up in the alcohol layer. This here, this violet colored layer, that's, I guess it's kind of like a blue violet. That's the emulsion. So this is a mixture of the salt water and the alcohol. And you'll see that's slowly gonna shrink over time. It does look pretty. I agree. You know, it's just kind of fun. Let's do some acid over here. I'm adding acid to the flask on the left. It's hydrochloric acid, the same acid that's found in your stomach, but this is a lot more concentrated, baby. A lot more concentrated. Like 100 to 1,000 times more concentrated. Ismail, what experiment we're doing? We're doing a bunch of experiments. You hang out with us, and we're gonna get you up to speed. Just ask some questions, we'll get you there, okay? But in this flask right here, I have some hydrochloric acid. Got some hydrochloric acid. Excuse me, I have some, what am I talking about? I have universal indicator in water. Universal indicator shows these different colors at different pH values. All right? And so right now I see in this flask, it's acidic, it's pH 3. So I'm gonna add some base to this flask, which will increase, I agree there, Carrie. We're gonna add some base, which will increase the pH. Here we go, up here at the top, I'm gonna add some base. Let's go 2 drops, 1, 2. You'll see it turn violet where the base goes. And then the acid and the base react. They're gonna perform a whole bunch of colors as they neutralize each other. Maybe they won't, maybe it'll just be red and violet. There it is, I'm seeing some blue, I'm seeing a flash of green, a little bit of orange and yellow, a lot of green now, a little bit of red on the inside of the vortex surrounding the middle violet. And it looks like I added a lot more base than acid, and I can tell that because it's now violet as it's equilibrated. So that tells me my pH is 10. I added a high excess of base. Hello there, Sora. Oh, Reboard, I'm so sorry. Yes, sodium hydroxide is a strong base. Thank you there, Sora. Let's add some acid to this flask over here. All right. Let's make it pH 4. This is for you, Raj Bannock. Here we go. 1 drop of acid. Boom, in it goes. You can see sort of the red where the acid has been added. We'll keep track of the pH over here. And that acid, when it goes into the surrounding violet, it'll neutralize a little bit of it. Hey, thank you, it's the guy. I appreciate that. Thanks you there, Zentavia, I'm guessing. Is pH 10 water okay for drinking? It depends, Sora. It depends on the concentration of the base and what the base is that's in the water. Well, welcome back, Shadow Kit. Thank you there, Redboard 7. All right, let's add another drop of acid. In goes 1 more drop. I've added it to this flask over here. Now you can see a lot more of the acid that's there. Will there be a point if you keep on adding acid or base that the pH will no longer change? Yes. Yes, that's correct. Because I don't have it here, but it's violet at pH 10 and up, and it's red at pH 3 and down. So I can't distinguish between pH 3 and 2 in the experiment. But hey, look, our pH is now 8. I've added enough acid to drop the pH by 2 units. Let's add another drop of acid over here on the left. Yes, that's right, Mr. Talent. And here in the United States, we use the word base and alkali synonymously. So basic and alkaline mean the same thing for us here in the United States. Thanks for pointing that out. Zentavia was just about to say you wouldn't want to drink something too high in pH. pH 7 is indeed what our body's usually at. And hey, look, I've added enough acid. I think this is going to equilibrate at about pH 6. About pH 6. It did, didn't it, Raj? Okay, let's add another drop of hydrochloric acid, and it goes, boom. There goes the red. Mr. Talent, you asked a question. I don't remember what it was. Hold on, let me go back and see if I can find it. Mr. Talent asked, is base another word for alkaline? Do I know the reason? I do not, Mr. Talent. I apologize. Yes, rainwater is slightly acidic. Looks like we're down to pH 5. Looks like we're down to pH 5. Let's add another drop of acid over here on the left. Boom. I think we're down to pH 4. Yeah? Let's add 2 more drops of acid, get us down to pH 3. No, I caught you, Mr. Talent. I don't know. I apologize. I think we're down to pH 3. Somebody asked if I keep adding acid, will the colors stay that way? Let's keep adding, all right? Let's just keep adding. All right, watch this. I'm going to add a drop of the acid. I'm adding another drop of acid. You can see the drops up there at the top. As I continue to add drops of acid, the color stays red. So this is red at pH 3 and down. What if I stuck my hand in that? Nothing really. I mean, it's you know, it's just not good technique, right? What's the molar concentration of the acid that I'm adding? About 6 molar. Roughly 6 molar, Slay. 5 or 6 molar. Felix, with the experiments I'm doing with strong acid and strong base, the carbon dioxide does not affect the experiment much. All right, now that we're at low pH, I'm going to start adding base. You got it, Jurgen. Here we go. Let's start adding drops of sodium hydroxide. Here we go. 1 drop. Now we're going to start increasing the pH. You can see the violet go in where I added the sodium hydroxide. That's very high pH, pH 10. But when it hits the surrounding matrix of low pH, it gets neutralized. Boy, look at that violet vortex. If I stop adding the acid, it will go to 10. Is that concerning? Paxton, I apologize. I don't understand the question. Thank you there, noob. Another drop of acid. So Shiazapora was studying chemistry earlier and having trouble understanding electronic configuration. Apparently, the third shell holds up to 18 electrons, but you've been told it's 8. So, oh boy. Okay, so you might have to remember in the third shell, you can have a 3s orbital, which holds 2 electrons. You can have you can have the 3s subshell, which holds a total of 2 electrons. You have the 3p subshell, which holds a total of 6 electrons, because there's 3p orbitals. And then you have the 3d subshell. So those, you know, the 3d subshell is, I'm going to add another drop of base over here on the left. The 3d subshell, you know, that's representative of the atoms, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, right across that first row of the transition elements. So because you have the 3s, the 3p, and the 3d subshells in the third shell, it is the case that it holds 18 electrons. Hope that makes sense. Ask more questions if you're not following. I think he's great, communist. Thank you there, B. Vasquez. Yeah, so my base is a lot more concentrated than my acid, which is why the color changes so fast. Quantum Burger, it is organic compound. So here are the substances that make up the universal indicator. It's going to be thymol blue. I apologize, I don't have the chemical structure, but this is an organic compound. It's got to have methyl red. It's going to have bromothymol blue, and it's going to have phenolphthalein. And all together, that gives you your universal indicator. Shiazapora. So the first shell can only hold 1 subshell, the 1s. Right? The first shell only holds s orbitals. The second shell holds 2 subshells, the s and the p subshells. It does not hold 3. The third shell, now it can hold the d. Now it can hold the d. So the third shell has 3 subshells. The fourth shell has 4 subshells, and so forth. So Zapora, now that you're taking, thank you there, Quantum Burger. Now that you're, taking higher level chemistries, we're expanding on the knowledge. We do teach some shortcuts when you guys are younger, and then, as you're able to handle more complex information, we throw it at you. All right, let's look at this flask over here, which is kind of cool. This flask over here, also, it has the same dye in it as this does, right? So this has universal indicator in it, and this has universal indicator in it. This is universal indicator at like pH 10, but there's 2 layers. Why are there 2 layers? Well, there's all these different compounds in universal indicator. Some of them dissolve better in the saltwater layer, and some of them dissolve better in the alcohol layer. That's it. So watch, to just show you that this does contain universal indicator, I'm going to add, this is very basic in here, I'm going to go ahead and add some hydrochloric acid. Hydrochloric acid is the same acid that's found in your, yes, different densities than Tavia. So it does have phenolphthalein, this male. That ends up in this layer here. I'm going to add some hydrochloric acid, okay? And in it goes. Boom, boom, boom. 3 drops. Let's see what happens. I see it. Do you see it? Come on. You can see right there. You see where the acid ended up. The acid that I added is more dense than the alcohol layer, but less dense than the saltwater layer. We can tell this is acid because if we get out our pH indicator chart, you know, it's looking like pH 4 right there, right? That's where I added the acid. It does look like a sunrise horizon. Come on, man. It sure does. It sure does. I see it, Camdaman. There it is. It does look a little bit like a horizon. Let's zoom in on it. It's like the beach. Ah, it's like we're at the beach. It's summertime at the beach. Okay, that's enough of that. Okay. All right, let's shake this up. So, it did look like a wildfire. Different densities cause them to layer differently in TV. You are right. Okay, thank you there, Slay. Now, this is basic, right? The surrounding medium is basic, like pH 10, but I've added some some acid. So that means this is going to get neutralized, which means the pH is going to drop. Let's find out to where. Well, I don't know. If there's more acid, it's going to be like yellow, orange, or red. If it's perfectly neutralized, it'll be green. If I didn't add enough acid, it'll remain blue or purple. Let's find out. Here we go. Give it a shake. Oh, man. There, I did not add much acid. I didn't barely change the pH at all. There must be a lot of base in there for sure. Hey, Ismail, thanks for hanging out. It was great having you on board. Thanks for commenting and all that. Here we go. Let's put a little bit of base over here in this flask on the left. Let's go 1 drop. See if we get the rainbow. Come on, baby. Come on, give me the rainbow. Let's go 1 more drop. Come on now. Come on, they want to see that rainbow. The base there it is. The base I'm using is 20% by weight sodium hydroxide. I think we got almost all the colors of the rainbow there. Kind of nice. Thank you there, Yarbot. Thank you there, Felix. Oh, yeah, we can see the separation happening here. Let's add some acid while the separation is happening. So remember over here on the right, we have the universal indicator, but it's also got salt water and alcohol, and they don't mix. I mean, they'll mix transiently, so you can see the 3 different layers. Shadow Kit, asking if something is toxic is a very complicated question because everything is poisonous and nothing is poisonous. It's the dose that makes the poison. If you drink enough water quickly enough, you will die. So water is toxic. Having said that, I wouldn't want to drink this because it wouldn't be good for me. I wouldn't want to swallow that amount, okay? So the problem with asking about toxicity is you have to know how much is present, how much it takes to hurt you, how long it takes for you to be exposed to it for it to hurt you, and how quickly it responds to, it'll attack your body. It's a very complicated question. Gaming, sure I do. All right, let's add some acid to this flask over here. I'm going to add like 5 drops. 1, 2, 3, 4, 5, and it goes. You can see that the acid, you can totally see that's more dense than the alcohol layer. It's less dense than the emulsion. The emulsion is a mixture of the alcohol and the salt water. Yeah, so you can, that's cool. That's really cool. We got like a 4-layer, we got a 4-layer flask going on over there on the right. Can it carbonize sugar? No, Felix. This is not the type of acid that'll carbonize sugar. That's sulfuric acid. I'm not using sulfuric acid. Gaming Fishy, we are doing some of the color separation experiment. I'm adding a little bit of acid over here to the flask on the left. Isn't that beautiful? Let's shake this up, shall we? So we know the surrounding matrix is like pH 10. I've added some acid. Let's see if I've added enough acid to neutralize the base. If I've neutralized it, it'll turn green. If I've added an excess of acid, it'll be orange, yellow, or red. And if I've haven't added enough acid to neutralize the base, it'll remain blue or violet. Here we go. Let's give it a shake. Oh, it's looking like it's going to be orange. But wait, there's some violet in there still, and it's going to green. I think that's where we're going to end up, folks. I think I perfectly neutralized the base, and so we have a green mixture, green pH 7. I neutralized it. A lot of comments coming through. Give me a little chance. I'm going to try to read that. Does sulfuric acid have a negative pH? Felix, it depends on the concentration of the sulfuric acid. If it's higher than 1 molar sulfuric acid, then it will have a negative pH. Raphael loves it when we have the layers. Are the levels of acid so low that it doesn't affect the bottle? Yes, that's correct, Raphael. Thank you there, Austin. You got it, Ismael. That's right, Felix. Thank you there, Felix. Thank you there, Zentavia. Beautiful shade of green. Green, I gotcha. Thank you there, Mezzy. All right. Woo. Hey, there we go. Ismail, you got it. Propane to all. Hey, thanks there, Andrew. Appreciate that. Appreciate that. All right. At some point, I'm going to have to turn this live off, but before I do, I usually turn the camera around and talk to everybody. If that's something that you might be interested in seeing, I'm going to warn you right now, I'm a 57-year-old man. If that's not something you want to see, then now's your time to get out of here. All right? Because I am going to be turning this... Oh, jeez. Sorry about that, folks. What an... it's just... Sorry about that, folks. I just banned him. What a piece of crap. Thanks, Zentavia. Yeah, I apologize. Nope. Sorry I missed it. All right. All right, let's get back to the science, all right? Yep, move on. Okay. So a little bit of, like I was saying, I'm going to, be turning the, camera around and talking to you all for the last little bit of those, of the live. I am an old dude. So again, if that's not something you want to be seeing, now's your time to maybe head on out. Let me add just a little bit of acid to this flask. It usually, I have noticed that if it's quite basic, that that sometimes the bottle starts leaking. So I like to acidify the bottle, or the contents of the bottle. Thank you there, like dogs. So yeah, you see I had a little acid. You can tell that acid is more dense than the alcohol layer, less dense than the saltwater layer. Yeah, there we go. Hello there, Melissa. I agree. Going to give this a nice little shake. I also need to acidify this flask. I'm going to do that real quick because if I leave it basic, there's like a shift in the lighting. That's kind of neat. I don't know how that happened. So I'm going to go ahead and add some hydrochloric acid to the flask over here on the left. Because if I leave it basic, I just leave these flasks out. And if I leave it basic, mold tends to grow in them. So that's why I'm acidifying everything. It is very cool. I just did it like dogs. I put some acid in there. That's a complicated question, Ismail, about limiting reagents. That's not something I'm going to be able to do on a live without being able to write a bunch of stuff. So how's it work? All right, Becomey, you love. Oh, I can't figure out what your name is. I'm so sorry. BOMG love. So sorry. I'm murdering your name. I apologize. Anyway, what I have in here is some universal indicator. Universal indicator shows these different colors at different pH values. All right, so I can see in this container over here, the pH is 3. I'm going to go ahead and add some base to this container on the left. The thing spinning on the bottom, Habib, is because there's a little magnetic stir bar. In goes a drop of base. In goes another drop of base. So there's a little magnetic stir bar. It's magnetic inside the flask. We got the rainbow, folks. That looks kind of nice. And it's sitting on top of a magnetic stir plate. What a magnetic stir plate is, it's like you can see it's like a magnetic stir. It's just like a little fan blade in here, and the fan blades are magnetic. And when it stirs, it causes that little magnet to stir. Here, if I turn it off, it stops stirring, like that. I'll turn it back on because I need to acidify this. Let's acidify this so a bunch of mold doesn't grow in this over the week. I usually do my lives around this time on Sunday. Within like a 2 or 3 hour window of this time is when I hang out. Thank you there, Raj Banik. Hello there, KS7. Welcome aboard. Oh, man. All right. It's time to hang out and just talk for a while, and then it's going to be time for me to end the live. So if you don't want to hear me talk, you don't want to hear me jabber on, now's your time to get out of here, all right? Fair warning. Thanks, Zentavia. How we doing, everybody? How we doing, everybody? Here, let's do this right. That may look a little better, huh? Thanks there, Raj Bank. Thanks there, James. Say my name, folks. Say my name. Thanks. Thanks there, DJ. Hey, Chris from the United Kingdom. Welcome aboard. Say the right name. Tommy Technetium. Thanks, Quantum Burger. Thanks there, James. JFK, why does it change color? It changes color because I put an indicator dye in there called dyes called universal indicator. Universal indicator changes color depending upon pH, which is how acidic or basic something is. So you're going to see these different colors depending upon whether I add acid or base. The more acid it gets, the more it shifts this way. The more basic it gets, the more it shifts this way. And it's perfectly neutral. It's going to be green, pH 7. Thanks there, Raphael. Thanks there, Chris. That's fine, James. It's all in good fun, right? It's all in good fun. Oh, cool, Andrew. What kind of experiments did you do? That's Zentavia. That's correct. At some point, it's just red. It just stays red. Hey, thanks, Raj. Appreciate that. That's correct, Quantum. Oh, how'd it work, Andrew? You got the pH rainbow and a burette. So I'm guessing what'd you do? I'm guessing you filled the burette with something like sodium carbonate solution and added a few drops of hydrochloric acid solution at the top with universal indicator or something similar. That's what I'm guessing. Hello there, Gamer. Gamer X, welcome. We had a good time today, folks. It was a good live today. Was a bit thin in the intermediate zone between the extremes. Spot on your guess. Great to hear. Come on. I tell you what, like dogs, I'll tell you what, that had nothing to do with me. Had nothing to do with me. If you started with a 73 and you pulled it up to an 89, that's you. That's all on you. Congratulations. Way to go. What hat is that? That's the Heisenberg hat, man. Right? Just Google Heisenberg hat, and you can pick some of these up. James. Thanks, James. Happy to see you. Hello. Sorry you missed us. If a very strong base is added, I heard that pH can exceed 14. How is this possible? So Ismail, so the pH is the negative log base 10 of the proton concentration. If you had 1 molar sodium hydroxide or higher, let's see, your POH is going to be 0, which is going to make your pH 14. So it all just deals with the mathematics of how we calculate pH. So, I mean, this is the equation that that you're going to need. So your pH is your negative log of your H plus concentration. Negative log base 10. Sorry, it's reversed. Here, let's flip it around. Your pH is your negative log base 10 of your proton concentration, and your pH plus your POH is 14. So if it's the case that you can get negative pHs, which you can, if you have concentrations of a strong acid at 1 molar or higher, you can get a negative pH. That means your POH can be, if you have a pH of 14 or higher, all that means is your pH is going to be negative. That's all that means. So just like you can have a negative pH, you can have a negative POH. And you say, well, what's a POH? Well, that's just the power negative log of your hydroxide concentration. If you don't know what I'm talking about here, then it's going to take more than this short live to help you figure that out. Thanks here, Felix. I'll take it. I will take it. Zentavia's going to college for meteorology, learning about chemistry and how it interacts with your atmosphere. That's cool. That's cool. Thanks there, Like Dogs. I'm doing well there, Real Siam. Can I give you organic chemistry hypnosis? You don't want to get organic chemistry from me. I did well in it, but I did well in it in the 1980s and the 1990s. That's the last time I had a course in organic chemistry. So you don't want to be taking organic from me or getting any organic information from me. Maybe you can do a hypothesis on how the ozone layer is affected by, I'm guessing you're saying chlorofluorocarbons. That was worked out, Zentavia. That was worked out in the 1980s by Molina, who won a Nobel Prize for that. Thank you there, Yor. I'm doing well, Real Siam. So Quantum Burger's favorite branches of chemistry are organic chemistry and physical chemistry. Well, I'm a physical chemist. That's my training. I got my PhD in physical chemistry, but I worked in a biochemical lab on photosynthesis. But I do like physical chemistry the best. All right, folks. Great hanging out with you today. We'll take this off. See, pop this on. Thanks for hanging out. We did a lot of cool experiments. I had a good time. It was a great live. Had a great time with everybody. Asked a lot of great questions. We saw some really cool stuff. Maybe we'll see you next week, all right? Usually I do my lives around this time, a little earlier. We're ending up, this is where I'm at. It's 4 p.m. Eastern. So, I had the same time as New York City. I usually run the lives New York City time, somewhere between 2 and 4 p.m. is usually when I start. So Thanks there, Raj. Great to hear it. So long, James. You all have a great day, and be always looking for the beauty that's around you and thinking about the science behind it. So long, folks.